Welcome to welcome to this video lecture session once again. So in this lecture session, we are going to see some practical problems in N-gram model. Okay. So before we are starting this particular lecture session, we will quickly recollect what we have discussed in the previous session. Okay. So previous session, we have started discussing about the concepts of N-gram language model. So there we have discussed about the role of language models, especially we have discussed about N-gram model, and also we have discussed about maximum likelihood estimation. So this is what we have discussed in the previous session. So we have discussed about what is language model, and then we have discussed about, especially in our context, what is N-gram model, and then we have started discussing about how N-gram model is used, where it is used, and what are all the mathematical concepts behind that. So these are all the things we have discussed in the previous lecture session. And also we have started discussing about what is unigram, what is bigram, what is trigram, and how it will be used the previous words or history to find out or predict that particular word or letter. This is what we have discussed in the previous sessions. Okay, so today we are going to see some practical problems with related to N-gram model, and then we are going to discuss about what are all the challenges we are facing while we are using the N-gram models or various N-gram models, and then we are going to discuss about how smoothing approach can be used to solve such a challenges. Okay, so these are all the things we are going to discuss in this particular lecture session, and finally we are going to discuss about what is perplexity. So these are all the basic topics we are going to see in this particular lecture session. So first we are going to see some practical problems related to N-gram model. Okay. So before that, I quickly recollect, okay, so what are all the types? So first one we have started discussing about unigram. Then we have started discussing about bigram. So then trigram, then 4 grams. So it will go up to N-gram. Okay. So these are all the things we have discussed, and then we have discussed about how these N-gram models, what are all the steps it deployed to predict the word or the occurrence of word in the particular context. So how it will work? So we have discussed about the conditional probability formula, the occurrence of variable B if variable A is given is equal to joint probability of A and B divided by probability of A. So this is what we have discussed, conditional probability. So from that I am rewriting that formula. So P of A and B, that means probability of occurrence of the word A and B together, is equal to probability of B if A is given divided by probability of A. Okay. So this is for two words. Suppose multiple words are given, or otherwise 4 words are given. So in that case, how we can rewrite? So this will be rewritten as A, B and C, D. So 4 words, probability of occurrence of 4 words is equal to, so now I am applying the chain rule. Okay, what is chain rule? So first word is an independent word. So I am taking as it is probability of occurrence of word A into probability of occurrence of word B if word A is given into probability of occurrence of word C if the word A and B is given into, and probability of occurrence of word D if the previous word A, B, C is given. So this is how I rewritten that probability of occurrence of word A, B and C and D in the sentence in order to estimate the higher probability of occurrence. Okay. So these are all the basic formulas. We have to keep it in mind while solving the problem using any one of the models. Okay. So what is unigram model? So we are calling it as 1-gram model. Okay. No history is used. So what is bigram model? Here in short we are calling it as 2-gram model. So here one word history is used. Similarly, what is trigram? In short, we are calling it as 3-gram model. Here, how many word history is used? 2 words history is used. Similarly, it will go on. Okay. But the better practice is, so better try to solve the problem or better try to find the occurrence of words using bigram, trigram or these cases 4 grams. Okay, don't go beyond that. Okay, so this is the some best practices. Okay, anyhow. So now we will see some practical problems so that you can able to understand better how these various language models are used to predict the occurrence of words. Okay, so now we will see some practical problems. 1 minute. They are removing the projector. Okay. So first, so what is the question here? So what is the most probable next word predicted by the bigram model for the for the following word sequence? Sorry. Okay. So once again I repeat the question. What is the most probable next word predicted by the bigram model for the following word sequence? Okay. So here the corpus is given for our reference. So first sentence started with the starting sentence, followed by the sentence I am Henry, and end with the end of sentence. Okay. Similarly, second one. Third one. Fourth one. Fifth one. Do I like Henry? So next one. Do I like college? Next one. I do like Henry. Okay. So one. Okay, so these are all the sentences given in the corpus for our example problem. Okay, now once again I repeat the question. So we are going to find the most probable next word. So using the model bigram for the following word sequences. Okay, so what is expected to find? So starting sentence, do, after that, what is the word is going to occur here. So this is what we are going to predict. So which model we are going to use? We are going to use bigram model. Okay. Okay, understood. Okay, so this is the expected question. Okay. So first step, if the problem comes like this, so how we are going to use bigram model, we are going to see. We know conditional probability formula and also we know maximum likelihood estimation. Okay, so how we can write for bigram model? So probability of occurrence of word I if word I minus 1 is given. Okay, equal to, I am rewriting as per bigram model. Okay, probability of occurrence of W of I minus 1 and W of I divided by probability of W of I minus 1. I hope if you see the previous video lecture, you will very well understood what is y of I minus 1, what is y of I, everything. So for your understanding purpose, I am referring quickly. So in this particular sentence, okay, the word which you are going to predict, so that word we are calling it as W of I. Okay, then which is W of I minus 1, that is the previous word W of I minus 1. Here which word is W of I minus 1? The word do we are noting it as W of I minus 1. Okay, so I hope you understood. Okay, so now it will be given as count of W of I minus 1 into W of I divided by count of W of I minus 1. Okay, now, so this is the mathematical formula. Now what I am going to do, what is the first step I have to do? Okay, so I am going for checking the given corpus. So from that I am going to refer the individual word and its frequency of occurrence in the history. Okay, so I am going to start from the starting of sentence. Okay, here how many sentences are there? Totally 1, 2, 3, 4, 5, 6, 7. Totally 7 sentences are there. So what is the first step I am going to do? First step, I am going to write individual word. Okay, so I am individual word and its frequency of occurrence. Occurrence in the given corpus. Okay, so I hope you understood. Okay, so what is the first step I am going to do? So from the corpus, given corpus, I am going to take individual word and how many times it occurred in the given corpus. So this is what I am going to do. Okay, so I am putting the tabular column. So one is word, next one is, we can say, frequency of occurrence. Okay, so now I am writing. So first I am taking the starting of sentence, first sentence. So how many times it occurred? 1, 2, 3, 4, 5, 6, 7. Okay, so I am writing. So starting of sentence, it occurred for 7 times in the given corpus. Similarly, ending of sentence also occurs 7 times. Okay. So next I am checking the word I. Okay. So how many times it occurs repeatedly? One time. Second time it occurs. Then third time, fourth time, fifth time, sixth time. Okay. So the word I occurs 6 times in the given corpus. Okay. Similarly, next word am. So check how many times it occurs. One. Second sentence there is no word am. Third sentence also no. Second time it occurs in the fourth sentence two times. Okay, the word am occurs 2 times. Okay, similarly the word Henry. So Henry, how many times it occurs? One. Here no. Second time, third time, fourth time, fifth time. So the word Henry occurs 5 times in the given corpus. Similarly, I am checking the remaining words. I already I have written, so no problem. Like. Okay, so like how many times it comes? 1, 2, 3, 4, 5. 5 times. Okay. Similarly, next one, college. Yes. So college, how many times it occurs in the given corpus? 1, 2, 3. 3 times. Okay. So any other word is remaining? So any other word is there? Okay. Almost we have covered all the words. Okay. So this is the first step I have written from the given corpus. The word, individual word and its frequency of occurrence. Okay. Next what I am going to do, I am going to use bigram model and I am going to predict which word is going to appear here. This is what I am going to do now. Okay. So what is bigram formula? We already discussed, right? So now I am going to write once again for our convenience W of I minus 1 equal to count of what we have to write W of I minus 1 and W of I together. Okay. Similarly, count of W of I minus 1. Okay. So in this particular sentence, what is W of I minus 1? It is the word do that we very well know because we are going to predict W of I, the word. Okay. So which is the previous word? That is W of I minus 1. W of I minus 1 is do. Sorry. So 1 minute. Okay. So we have very well known. Okay. So the word we are going to predict, we are mentioning it as W of I. So which is the previous word that we are calling it as W of I minus 1. Which is the previous word that we are calling it as W of I minus 2 and it will go on. W of I minus 3 and it will go on. Okay. So in our bigram model, only one word history is used. That means previous word, only one word we will take for predicting the current word. Okay. So now what is W of I minus 1? That is do. So I am substituting in this formula. So count of do. Okay. So that means the word do, how many times it comes in the given corpus. Okay. Sorry, I didn't write for the word do. Okay. Now check do how many times it repeats. So here no, there is no word called do. Here there is no word called do. Here one time, second time, third time, 4 times. Okay. So the word do 4 times it repeats in the given corpus. Okay, now substitute this 4 here equal to 4. Okay, so now you understood, right? So how to use it? Okay, so the word do 4 times it repeats in the given corpus, or 4 times it occurs in the given corpus. I am mentioning there. Okay, so now here from the given corpus I am going to check, so how many times the words are repeating. Okay, so here first I am going to check for, so I am leaving the starting of sentence, it will occur only one time at the start of the sentence. Okay, I am leaving this one, I am taking the next one. Okay, so I am going to check the probability of this particular sentence, how many times it repeats after the word do, after the word do. Okay, this is what I am going to find it out. Okay, so now I am substituting in the given formula. So probability of end of the sentence, occurrence of end of the sentence after the given word do. This is what I am going to find it out. Okay, so how I write the formula? Using maximum likelihood estimation. So count of W of I minus 1 and W of I together. Okay, so what it means? Do and end of the sentence. Okay, what about the denominator? The denominator is W of I minus 1. What is W of I minus 1? It is do. Okay, so count of do. Okay, that is count of do. I hope you understood this one, right? Now I am going to check the denominator. I know the value is 4. Okay, the denominator value is 4. So what about the numerator value? Now I am coming back to the given corpus. Okay, and I am finding how many times after the word do the end of sentence comes. Okay, so I am checking in the first sentence, after do there is no end of sentence, leave it. Second one I am checking, no. Third one I am checking, no. Fourth one I am checking, no. Fifth one, sixth one, seventh one, there is no occurrence of that particular sequence. Okay, so I am writing it as 0. Okay, the answer is 0. Okay, so first one I have predicted, P of after do equal to 0. Next I am going to find for the word I after do. Okay, that means probability of occurrence of word I after the word do. So how we have to rewrite the formula? So count of do I divided by count of do. Okay, so remaining denominator we very well know the value is 4. So I am erasing this one. Okay, so what about this one? Similarly, I am going to check in the corpus. Okay, I am checking how many times in the sentence the sequence do I comes. Okay, so first one no, second one no, do I there is no, third one also no, fourth one also no, fifth one if you check here do I comes, the sequence. Sixth one also do I comes. How many times it occurs? 2 times. Okay, so I am taking, so the value of or the count of probability of occurrence of the word do and I together is 2 in the given corpus. Okay, so I am writing here. Okay, 2 by 4 is 1 by 2. Okay, so I am writing it as here. It is 1 by 2. Similarly, next one. What is next one? Probability of am divided by do. So now denominator is 4. That we very well know. Okay. So what about numerator? So how many times after do am comes? Okay. So do am no, no, no. Here also no. In this sentence also no, no. So 0. Okay. So it is equal to 0. So equal to 0. Okay, so I am rewriting here, it is 0. Okay, similarly, I am checking for the word Henry. So how many times the word Henry occurs after the word do? Okay, so the denominator value is 4, we very well know. Okay, for the given corpus. Okay, next we are going to check. So how many times the sequence of word do Henry occurs in the given corpus? So first sentence, do Henry, no. Second sentence, no. Third sentence, it occurs one time. Okay. Fourth one, no. Fifth one, no. Sixth one, no. Sixth one also, no. So the sequence of word do Henry occur only one time in the given corpus. Okay. So it is 1 by 4. Similarly, next one, probability of like given is do. Okay. So this is what we are going to discuss. Next one. Similarly, the denominator value is 4. Okay, the denominator value is 4. What about the numerator value? How many times after do like comes? Check here. No, here no. First sentence, second sentence, no. Third sentence, no. Fourth sentence, no. Sentence only one time. Last sentence only one time it occurs. Okay, the value is 1 by 4. Okay, similarly, check for college. How many times the word college occurs after the word do? Equal to. Okay, so check here. College, no, no, no. So that is also 0. Okay, last one. How many times the word do occur after do? So that is also 0. Okay. So here, while I am checking the probability of occurrence using bigram, okay, so I got 3 different probabilities. One is for the word occurrence of word I after do, that is 1 by 2. Okay. Next one, probability of occurrence of word Henry after do is 1 by 4, and probability of occurrence of like after do is also 1 by 4. Here, which one is having highest probability? The highest probability is the occurrence of word I after do. So bigram model will select this particular word I and it will substitute here. Okay, so what is the answer for this particular problem? So it comes starting sentence do I. Okay, as per bigram model. Okay, so I hope you understood. Sorry, 1 minute. So once again I repeat the steps. So whenever the problem given like that, so first step to write the tabular column, so contains individual words and its frequency of occurrence in the given corpus. Okay. Once complete that step, next step is to find which word occurs most of the time after the previous word using bigram model. Okay. So this is what we have discussed. Now we will see one more problem so that you will understand better. Okay, so I am taking the same corpus. Okay, same example. So what is the sentence? So I like Henry. So I like Henry. So after that, what is that word? Okay, so using bigram, I am going to find it out. Okay, so this is what the given problem. Okay, so using bigram, I am going to find out after the word Henry, which word is going to occur. Okay, so this is what we are going to find it out using bigram model. So what is the first step? I am writing all the individual words and its corresponding frequency of occurrence. So that is done, already done. Okay. What is the next step? I am going to find out the probability of occurrence. Okay. So I am going to substitute the formula. So in this particular sentence, what is W of I minus 1? W of I minus 1 is Henry. Okay, this is W of I minus 1. So W of I we are going to predict using bigram model. Okay. So here while I am substituting in denominator, what is the value of here? Count of Henry. Okay. So what is count of Henry? It is 5 times. Yes. So in the given corpus, the word Henry occurs 5 times. Okay. So I am writing here. So here all the denominator value will be 5. Okay. So now I am going to find out for each case. Okay. So probability of occurrence of end of sentence after the word Henry. Okay. So what about denominator? It is the value is 5. What about numerator? W of I minus 1 and W of I. W of I minus 1 is Henry. What is W of I am expecting? So I am checking the probability of occurrence for the end of sentence. Okay. Now I am coming to given corpus and I am going to check after Henry how many times end of sentence comes. So here first sentence 1 time. Then next one 0, 0, 0. Second time. Third time. So 3 times it comes. Okay. Next I am checking probability of occurrence of word I after Henry. Okay. So the denominator value is 5. What about numerator? Okay. That means after the word Henry, how many times the word I comes? So here no, here no, here no, no, here 1 time. Okay, only 1 time. So I am writing here. Next one, we are checking probability of occurrence of am after Henry. So the denominator value is 5. It is common. Okay. So after Henry, the word am. Here no, here no, here also no. No, 0, 0, 0. So it is 0. So equal to 0. It is 0. Next I am checking probability of Henry and Henry. It is 0. Next I am checking probability of the word like after Henry. Like after Henry, we will check it. Okay, so the denominator value is 5. What about the numerator value? Okay, so how will you write the numerator value? If you check the formula, Henry like. Okay, we will check here. Here no, here no, Henry like. Yeah, here it occurs 1 time. Here no, here no, here no, here no. Only 1 time. Okay. I am writing here. So similarly, next we are checking for the word college after Henry. So the denominator is 5. Okay, so what about, we will check in the corpus. So after Henry, college. No, that is 0. Last one. Do the word of occurrence of do after the word Henry. So I will check here. 0, 0, 0, 0. That is also 0. Okay. So here which one is common? Okay, most common occurrence is the end of sentence after the word Henry. Okay. So here 3 cases comes. Okay, this is one case. This is another case. This is another case. Okay. So what it means, there are three words that are frequently occurred after the given word, previous word Henry. So out of which I am checking which one is having higher probability. Okay, so in that case, end of the sentence has the highest probability. So I am choosing that one. So it will have end of sentence after the word Henry using bigram model. Okay, so I hope you understood. Okay, so now we have discussed the concept of bigram model. Okay, so how will you rewrite the formula? That is maximum likelihood estimation P of occurrence, that is probability of occurrence, the word W of I, if the previous word W of I minus 1 is given, because bigram will take only one previous word as a history. Okay, W of I minus 1 equal to probability of occurrence of W of I minus 1 and W of I, or otherwise we are saying count of, okay, divided by probability of previous occurrence of the previous word. So this is what about bigram model. Okay. Next we are going to check about how we can find the, or how we can predict the occurrence of word using trigram model. So till now we have discussed about bigram model. Now we are going to discuss about the trigram model. Okay. First we will rewrite the formula. Then after that, okay, we will see the problem. So what is trigram? I will recollect. So in short, we are calling it as trigram model. Okay. So it will use two previous word history. Okay. So this is the concept of trigram model. So how will we write the formula? So probability of occurrence of W of I, if W of I minus 1 and W of I minus 2 is given, it will be equal to joint probability of W of I minus 2, W of I minus 1 and W of I divided by probability of occurrence of W of I minus 2 and W of I minus 1. Okay, so I have rewritten the maximum likelihood estimation formula with the context of trigram. Okay. So once again I repeat, trigram, in short we are calling it as trigram model. That means in the given sentence it will use two previous words to predict the next word. So that is the concept of trigram model. Okay. So two previous words are given by the term W of I minus 1 and W of I minus 2. So this is the rewritten formula. Okay. Now we will see one problem so that you will understand better the concept of trigram model. Okay. So this is the given sentence, do I like? So the expectation is I have to predict the word, which word will occur in this given place. Okay. So whenever we are using trigram model, so we have to use two previous words. So what are all the words I have to use? I like. Okay. So this like word we are mentioning it as W of I minus 1. This word I we are mentioning it as W of I minus 2. And the word we are going to predict we are mentioning it as W of I. Okay. So I hope you understood this one. Okay. Now I am using the same corpus. Okay. So the first this step is also same. Okay. So up to this part, it is similar. Next, what I am going to do, I am going to first find out the denominator. Okay. So what about here in this particular sentence? W of I minus 2 is I. Okay. W of I minus 1 is like. Okay. Now I am going to check in the given corpus how many times this sequence occurs. That is, I like, how many times it occurs. Okay. I am going to check in the given corpus. So first sentence, there is no. Okay. Second sentence, if you see, it occur one time. Third one, no. Fourth one, no. Here again, second time it occurs. Again, third time it occurs. Okay. So the probability of occurrence of the sequence I like in the given corpus is 3. Okay. So I hope you understood. Okay. So here I am writing 3. Okay. Now what about the numerator? Now I am going to check for each cases. Okay, as like bigram model, we are going to find out for each case what is the probability of occurrence. So first I am checking for the end of the sentence. Okay, so the denominator value is 3. Okay, I am substituting in that formula. Okay, what about numerator? After I like, how many times end of sentence comes? So that is what I am going to check. Okay, so after I like, after I like, how many times end of sentence come? There is no sequence comes like that. So the answer is 0. So here the value is 0 here. Similarly, I am finding for the next word I. Okay, so how many times I comes after I like? Okay, this is also 0. Second, I am checking for probability of occurrence of word am after I like. Okay, so denominator is 3. Okay, so after I like, how many times the word am comes? This is also no. The answer is 0. Similarly, next I am checking. So how many times the word Henry comes after I like, after the sequence I like. So the denominator value is 3. That is constant in this given problem. Okay, so how many times I like after that Henry comes? No, here also no, here also no, here one time. One time. Okay, after the sequence I like, the word Henry comes one time. I'm checking, no, only one time. Okay, so I'm writing here 1 by 3. Okay, then next one. So how many times like comes after I like? So this is also probably 0. Similarly, next one, how many times the word college comes after the sequence I like? This we will check. Okay, so how many times college comes after the sequence I like? So here one time. Second, here another time. Okay, 2 by 3. So 2 times it comes. So 2 divided by 3. Similarly, next I'm checking how many times the word do comes after I like. Okay, how many times the word do comes after I like. Okay, checking here, check here, check here, check here, check here. Do comes after I like. 0. Okay, so this also 0. Here, so with here only two probabilities occur. Okay, one is probability of occurrence of the word Henry after the sequence I like. Next one, probability of occurrence of the word college after I like. So here which one is most common one? That is 2 by 3. So we have mentioned as college is the most times it occurs. Okay. So I hope you understood how we can use using trigram model. Okay, so we will check one more case. We will go for the next case, that is the same one. Do I like college? Okay. So once again I repeat. So in this particular session, first we have discussed one problem by using bigram model. So how it worked we have checked. Now we have discussed about using trigram model, how we have predicted the word. Okay. Now we are going to use four-gram model. Using four-gram model, how we are going to predict the word of occurrence. Okay, in the given position. Okay, I am taking the same example. Okay, but I am going to use four-gram model. So first we will see the concept of four-gram model, and then we will see how we can rewrite the formula for four-gram model. Then we will see the example so that you will understand better. Okay, so the sentence is, do I like college? So after that, what is the expected word? So we are going to predict using four-gram model. So in short, we are calling it as four-gram model. So how many three previous words are used? Three previous words. Okay. Once again, I repeat. Four-gram model, in short, we are calling it as four-gram model. In four-gram model, we will use three previous words to predict the given word or to predict the next word. Okay. So here, what are all the three previous words? First one is W of I minus 1. Next one is W of I minus 2. Next one is W of I minus 3. So three previous words are used to predict the next word. This is what the concept of four-gram model. Okay, now I am going to substitute in this formula. So how will you rewrite? 1 minute, I will erase this one. So how will you write the formula? So W of I, if three previous words are given, I minus 2 and W of I minus 1, equal to probability of occurrence of W of I minus 3, W of I minus 1, W of I minus 2, W of I minus 1 into W of I divided by probability of occurrence of the word W of I minus 3, W of I minus 2, W of I minus 1. Okay, so this is the formula I have rewritten as per four-gram model. Okay, so first step, okay, so after changing it into individual word and its frequency of occurrence, I am going to find out how many times the probability of occurrence of these three words occur in the given corpus. Okay, what are all the three words together? I like college. So we are going to check in the given corpus how many times the sequence I like college occurs. Okay, so first one, no. Second one time. I like college occurs, one time. Third one, no. Fourth one also no. Fifth one, no. Sixth one, again the sequence occurs. I like college occurs. Okay, so in the given corpus, two times the sequence of I like college occurs. So what about the denominator value? It will become 2. Okay, so probability of, that is probability of I like college, okay, is equal to 2 because it occurs 2 times. Okay, so now I am going to check the individual cases. Okay, so the first one I am taking end of the sentence. Probability of occurrence of end of the sentence after I like college. I am going to check. What about denominator? It is 2. Now I am checking how many times after I like college the sentence ends. One time. Okay, one time directly. Second one, yes, 2 times. Okay. So the numerator value also it will become 2. The answer is 1. So I am writing the answer as 1 here. Okay, understood. Now I am checking for the second word. So probability of occurrence of word I after I like college. Probably it will be 0. Okay. Next I am checking what about the probability of occurrence of word am after I like college. Okay. The denominator value is 2. So numerator I am going to check. So how many times the word am occurs after the sequence I like college. So I like college, 2 times it occurs, we know. We directly go to that particular case and check. After that am comes, no, 0. Okay. After that I like college, after that am comes, no. So the answer is 0. So it will be rewritten as 0. Similarly, next check how many times the word Henry comes after I like college. Okay, so it is also 0. Then how many times the word like comes after I like college. So this is also again 0. How many times the word college comes after I like college. After the sequence I like college. So this is also 0. Fourth one, last one, how many times the word do occurs after I like college. So this we will check once again. So denominator value is 2 because in the given corpus 2 times the sequence I like college occurs. So here one, here one. I am checking these 2 sequences. After that there is no word called do. So that is also 0. Okay. So here if you check, okay. So here only one probability that is possible, that is after the sequence I like college, the end of sentence only most probably came. Okay, so here the answer is end of sentence. Okay, so I hope you understood. So once again I will repeat. Okay, so in this particular session we have discussed the practical problems for bigram method, trigram method and 4-gram method. Okay, so now we are going to see. Okay, so there are some 7 sentences given. Okay, so here I am going to find out. Okay, I am going to compare some 2 sentences and I am going to find out which sentence has the most probability of occurring several times or more number of times than the other statement. Or otherwise, I am going to compare 2 statements and I am going to say this particular statement has the highest probability of occurrence in the given corpus. Okay. So now I am taking 2 sentences. One is I like college. Next one, do I like Henry? Okay. So the given corpus, I am taking 2 sentences and I am going to check which statement has the highest probability of occurrence using bigram model. Okay. I am raising this one. Okay. So once again I repeat the question. So we are going to find out, okay, out of these 2 given sentences, which sentence is having the highest probability of occurrence. Okay. I am taking the first sentence. What is the first sentence? So that is, first sentence is statement I like college. College, end of the sentence. Okay. So now I am going to find out the probability of occurrence of this particular sentence. Okay, so how I can write probability of occurrence of I like college. Okay. Now what is the next step we will do? Okay. So we are going to use the chain rule. Okay. I am going to split into individual words and I am going to find out the probability of occurrence of each case. From that, I am going to find out the probability of occurrence of the entire sentence. Okay. Now I am taking the first case. Okay, so I am writing end of the sentence. So I am not going to bother about the starting sentence. So first one is probability of I. So after end of sentence. Okay. Then next one, I am going to find out like if the given word before previous word is I. Then next I am going to find college. Previous word is like. Then I am going to find out end of sentence. Given previous word is college. Okay. So now I have splitted as per the chain rule policy. Okay. Splitted the entire sentence into individual probabilities as per chain rule. Okay. Now dollar of yes. How many times it occurs? 7 times. Okay. First probability I am taking. Okay. 7 times it occurs. So out of which how many times I occurs after starting of sentence? Okay. So it is starting. Sorry. It is starting of sentence. Okay. So starting of sentence in the given corpus 7 times it occurs. I am writing here. Now I have to find out. So how many times after starting of sentence the word I occurs? Okay. So I am going to the given corpus. I am going to check how many times after start of sentence the word I occurs. 1 time, 2 times, 3 times. Okay. Now I am writing here equal to 3 by 7 into. Okay. What about the next one? Okay. So denominator probability of I. So here how many times the word I occurs? 6 times. I am writing here. Now I am going to check after I how many times the word like occurs in the given corpus. Okay. So this is what I am going to check. After I how many times the word like occurs? 1 time, 2, 3. Okay. So this is also 3. Similarly, okay. So how many times the word like occurs? 5 times. So 5 times the word like occurs. Now we are going to check how many times after the word like college the word occurs in the given corpus. Okay. So like college. So 1 time, 2 time, 3 time. Okay. So I am writing here. So it will become 3 divided by 5. Similarly, last one, how many times the word college occurs? 3 times. Okay. Now we are going to check how many times after college end of the sentence occurs. So after college end of the sentence occurs 1 time, 2, 3 times. Okay. So this is also 3. So it will be equal to 3 by 7 into 1 by 2, 1 by 2 into 3 by 5 into 1. Okay. So what is it? Okay. So 3 3s are 9, something 9 divided by 7 5s are 35. 770. Okay. So this is the probability of occurrence of this particular word. So $S I like college. Okay. Now similarly, we are going to check for the second statement. So what is the second statement we have chose? Do I like